Hello friends, in this video we are going to discuss about Skew Hermition matrix. So as I've already discussed in the complex matrix video, complex matrix are of two types, Hermitian and Skew Hermitian matrix. We have already covered the Hermitian matrix part, so in this video we are going to discuss about Skew Hermitian matrix. Now a matrix, let's say A, it will be called as Skew Hermitian if the transpose of its conjugate will be equal to minus A, means the negative of the same matrix, means each and every element of the matrix A will be multiplied with minus 1. If it satisfies this property, it is a Skew Hermitian matrix. Okay, this is the basic property of Skew Hermitian matrix. Now let us try to understand this with the help of an example. Let us say we have a matrix A which is given by 0, 2 minus 3i, 4 plus 5i, minus of 2 plus 3i, 0, so 1 minus 2i, then we have minus 4 minus 5i, 1 plus 2i and minus 3i. This is the matrix A. Okay, this is the matrix A. So first we have to determine the conjugate, the complex conjugate of matrix A. So the complex conjugate is determined for each element and it is done by keeping the real part as it is and inverting the imaginary part. So 0 will stay as 0, 2 minus 3i will become 2 plus 3i, 4 plus 5i will become 4 minus 5i. Minus of 2 plus 3i will become minus of 2 minus 3i, 0 will stay as it is, minus of 1 minus 2i will become minus of 1 plus 2i, minus of 4 minus 5i will become minus of 4 plus 5i, 1 plus 2i will become 1 minus 2i, and minus 3i will become plus 3i. Now we will calculate or evaluate the transpose of this matrix. Okay, A conjugate transpose. So the transpose of a matrix is determined by interchanging the rows and the columns. So the first row will become the first column, the second row will become the second column, and the third row will become the third column. So it is 0, 2 plus 3i, 4 minus 5i, second row will become the second column, minus 3i, 0, minus of 1 plus 2i, third row will become the third column, 1 minus 2i and plus 3i. This is A conjugate transpose. Now if we compare this matrix A, the original matrix A, with this matrix, the transpose of the conjugate of this matrix, compare it element by element, we'll see that each of the elements of this matrix is the negative of the original matrix. See here, 0 will stay as 0, no problem. 2 minus 3i, here it is minus of 2 minus 3i. 4 plus 5i, here it is minus of 4 plus 5i. Here it is minus of 2 plus 3i, here it is 2 plus 3i. Minus into minus becomes plus. 0 will stay as 0. Minus of 1 minus 2i becomes 1 minus 2i. Minus minus becomes plus. Minus of 4 minus 5i becomes 4 minus 5i. 1 plus 2i becomes minus of 1 plus 2i, and minus 3i becomes 3i. Okay, so this is the skew Hermition matrix. Each and every element of the transpose of the conjugate matrix is the negative of the original matrix. In Hermitian matrix, it was simply A conjugate transpose is equal to A. In case of skew Hermitian matrix, it is A conjugate transpose, the transpose of the complex conjugate of a matrix will give us the negative of the original matrix. Okay, so this is all about the skew Hermitian matrix. Okay, so these are the two basic concepts which are associated with complex matrix, the Hermitian and the skew Hermitian matrix. We have already discussed them both. Okay,